So these are some existing wooden stool designs. As you can see, some of them have similar types of joinery. So for example, these two here, both use a series of slots or slot and tab construction, as it may be called. If we look here, we can actually see that these are actually joined by a little thing called a dog bone. So a dog bone is called a dog bone because it looks like a dog bone. So essentially, if you've got a rectangular or square cutout into a piece of material that you're wanting to use with a CNC router or a CNC machine, that CNC router is going to be using a round cutting tool or a round end mill. Normally, I'll use a 6mm diameter or 4mm diameter tool. That means in the corner of each internal cutout or internal corner, there is going to be a radius of between 2 and 3 millimeters. Companies producing a large amount of cabinetry or doing cabinet fit outs or making furniture professionally might use a larger tool so that they can produce those in quantity faster. So for that, they may use a 8mm or 10mm tool. And a lot of cabinet companies will even use 12mm tools to cut their material. So that would obviously mean that a dog bone is necessary to deal with that. And you can see that here. There's a little hole which is visible. That's not always necessary if you're trying to produce things in quantity to go, to send out to a customer. Then it probably would be necessary to do that. If you're producing something for yourself, then that isn't really necessary because you can easily get a chisel or a file and you can actually get rid of that bit yourself. The advantage of doing it yourself is that you don't have to worry about that dog bone being visible. In fact, another thing you could do is if you got two parts slotting together, you could simply round over one of the parts to actually give it that radius. So you could actually keep those nice rounded corners within that slot. So those are two examples. This one here is a bit difficult to see exactly what type of CNC joinery it uses. I suggest that there is probably an additional plate underneath here which isn't visible from the top, and that these have a simple sliding joint which they slot together using. And the same would go for this one, and this one. This one looks like the corners are butt jointed, so there's probably some screws or something like that there. And this one looks like the majority of joints are actually mitered joints, which is something that you can also do on a CNC machine. If I was going to do this on a CNC machine, I would probably cut them purely 2D and then actually get that angle perfect on, say, a table saw manually. Because it can be a little bit tricky and time-consuming to set up that nice mitered joint for a small quantity run like this. If we look, this piece actually has essentially 3 sides, which means this angle here is going to be close to 120 degrees. So for that, you would probably buy a special 120 degree cutting tool. Which wouldn't be something you'd invest in for a one-off, for example. Underneath the top of the stool or table, whatever this is, there are probably some little slots in there, maybe half of the depth of the material, which that slots into. And those slots, again, aren't visible from the top, which is a nice element to add. It's important to think about how you can make those joints less visible unless you're going to use them as a design feature in your work. And you've got a nice radius on here as well. That looks good. So I might show in Fusion 360 how to do this style of thing and how to do the slot together. So for all intensive purposes, these two and this one are pretty much the same thing. You could even say that this stool down here is the same as this. If you look at how it's made, if you look at how it's designed, the actual joints and design work is very similar. The only difference between these two is really the shape. Something else to think about is maintaining the structural integrity. we're going to be going with a birch plywood of about 18 millimeters. And birch plywood, although it does have lots of ply layers, many more ply layers than conventional non-structural or CD pine plywood, it still, isn't going to be as strong as a steel chair leg. It will still bend. So you'll have to think about how you can minimize the length of the legs, or at least maximize the width. And this type of design is really nice because the legs are actually joining down the bottom. It will add quite a lot of strength that way. And this one as well, because the legs are joining down the bottom, it will add quite a lot of strength, which is quite nice. And the same with this one. They're using a concept of triangles to sort of direct the stress away from the actual material itself and push most of the load back up into the seat. Something to think about with this design would be how you actually join the pieces together. This looks like it's purely miters, which might be glued together. If you're a business trying to make a product like this, which you might send, via Australia Post or a courier, this looks like it might need to be glued together or assembled at the factory, which would make shipping and transportation a lot more expensive because of the volume of the item. If it's flat pack, it's very easy to send, and the customer just simply slots them together or puts a little screw in, similar to how an IKEA bookshelf or something like that might go together. This looks like it might be a little more complicated than that, but you're free to do some research into types of flat pack joinery and things like that they normally use. If you look closely, it looks like the design of this stool is actually tapered. The edge of the top of the stool is actually almost in line with the bottom of the foot. So it looks like the actual stool leg comes out about 50 millimeters further than the actual top of the leg. And they've probably done this by having an angle or miter joint at the top of this one as well. So when you think about it, the angles for this are actually quite complicated. You would need to think about it quite a lot to figure out exactly how many degrees that each angle needs to be. But I'm just going to leave this as a non-tapered stool. So I'm going to make this stool about 500 millimeters in height. So the first thing I'm going to do is I'll click Create Sketch and then select one of the planes. I don't want my leg to be any thinner than 70 millimeters. So whenever I'm drawing a line, or this is going to be a joint between the two pieces, but I'm still going to set this as 70 millimeters. If it's less than 70, it becomes really flexible. And for some designs, 70 millimeters would not be suitable at all. 70 millimeters is okay in this circumstance because the legs are actually being supported at the base by the other legs, which is taking a lot of the stress off them. Otherwise, you would find that it would be quite flexible. So if, for example, you made the bear chair with legs which were 70 millimeters wide, then it would be quite flexible. So if you were sitting on it and you sort of twisted your body around, you'd be able to feel the legs flexing. So I'm going to make the legs 500 millimeters high or 50 centimeters high. So I've got, and it's not equal on top and bottom, so I'm going to actually have to proportion it. So I might do 160 millimeters for this top bit. And then the bottom bit is going to have to be the remainder. And then a nice thing about Fusion or other CAD software is you can actually type in like an equation or a sum directly in there. So if I've got 500 and I want to subtract 70 and then 160, I can type in 500 minus 70 minus 160 and click enter, and it will actually add it up for me or subtract it for me. And you can do the same with the asterisk symbol to do multiplication as well. it's helpful to not have to grab the calculator out, especially for more complicated numbers. And I'll set that angle as 100 degrees. And now there is the opportunity for me to actually move this a little bit. The offset tool is going to allow us to create a line which is exactly 70 millimeters away from the other line. Let's go minus 70. Click enter. And now I'm going to draw this line again up here. I said it was going to be 30 millimeters, I think. Click enter. And I said this line is going to be 20 millimeters. There are some limits with offsets. Certain geometry, it will get unhappy about doing an offset. So now what I can do is I can draw a line down here. Click enter. And I can draw a line up from here. Click enter. And I can use the trim tool to actually remove these features that I don't want. So there is one part of the leg. This should fit together nicely because these features are actually in line. So now I'm going to go solid and then click extrude. I'm going to set this to be 18 millimeters. And I'll say that this is going to be a new component. That looks good. And so now I'm going to actually have to do not a fillet, but a chamfer. 30 degrees is the chamfer that we need. And click OK. And do that for down the bottom as well. 30 and 18. We click OK. So there's our chamfer. That looks like it's worked nicely. And then let's add another one on this side as well. Make sure we got this set to 18. And click flip. Perfect. That looks good. So what I can do now is, first of all, you probably want to save that, so quickly go File, Save. But what we can do is let's create mirror. And let's actually duplicate this component. The mirror plane, let's mirror it directly around the middle. Like so, that's great. And if we actually look where these planes are, it looks like we've got our part directly in the middle, which is nice. So then what we can do is we can click on one of them and we can click move. So let's rotate this one 60 degrees. And for now, we're just going to line it up by eye. And click OK. There are several different assembly tools that you can use as well. So I'm going to click Assemble Joint. Click there. And now I can click there. And click OK. And those two have joined together nicely and there won't be any gap. And then now what I can do is I can actually get another one of these. So I can go Control C, Control V, and I want to select capture position. Actually, let's copy both of these at the same time. So delete that one. Control C, Control V. Yeah, so now those are already, I don't think they'll be jointed, but that we've already got a copy, and let's rotate that around. This time it's 120 degrees, I think. Now let's line that up nicely. Click OK. And now let's copy these two again. Control C, Control V. We have another one, let's rotate that around 120 degrees. And so now they fit together nicely. So now what I'll do is I'll start using the assembly. So assemble is essentially a joint or a mate between faces. So I've selected a face there and a face there. Click OK. Those are now joined. Let's do the same for this one. Click OK. It's a bit of a gap down here. That's interesting. I didn't notice that before. I suspect that one of the lines might not have been straight in this sketch. So once we've drawn this up and joined these, I might actually go back and have a look to try to find the source of that problem. But it doesn't really affect what we've already made at all. So there's a slight issue obviously with that gap. So if I go back to the sketch, so with CAD modeling and parametric CAD, a program like Fusion, you can easily go back to the sketch to actually and click Edit Sketch. So if we see, I never actually joined these lines up. So these are actually always off by a couple of millimeters. So if I change that, if I line that up and click Finish Sketch, now it's actually going to update that change to all of the parts because all the parts are identical. So rather than me having to do all this again, I can really easily edit that. I'm going to create the top of the stool. So now I'm going to create a new sketch on top of one of the legs. So I can click a surface and click Create Sketch. And the first thing I want to do is I need to actually roughly find out where the middle point is. So I'm going to draw two lines across like so. And where they line up will actually be the middle. Or in fact, where the middle of that line is, is the middle. So now I can click Create Polygon, and you can use either circumscribed polygon or inscribed polygon. So I'll use circumscribed polygon, and I'm going to stretch it out like so. You could have it this way around or that way around, doesn't really matter. Just as long as you're, relatively consistent with how you do it. And then I can use the sketch tool to set a measurement of this. So I'm going to go with 400 millimeters, which is nice and even. And then I will also use the sketch fillet tool to round that off nicely and get rid of those sharp edges. It might be a little bit too much at the moment, so let's change that to about 40. That looks good. And click Enter. And I'm just going to delete that other line, or you can press X to convert it into a construction line or a sketch construction line. And so now I can go solid extrude, and I could actually easily extrude this out to 18 millimeters. And make sure you click New Component. Click OK. So now I've got this top of the stool done. Something to note here is that there's no joinery at the moment for this bit. So this bit would solely just be sitting in there. And as I showed you previously, it's really easy to go back and click Edit Sketch. So even though I've extruded this now, I could easily go and click Edit Sketch, and then I could add, say, a hole in the middle, or if I wanted a hole at the edge, it'd be really easy for me to dimension it, say to 10 millimeters. Go Finish Sketch, and go back to Edit Feature, and there'll be that hole there, and I can click that hole and go done, and then that hole has appeared. So without me having to redo this part again, I can easily add features like that. You know, you could add patterns and things like that just by changing one. You wouldn't need to change everything. So that is very helpful. So there's the completed still design. There really are a lot of options in how you could have a little recess to join that bit. It's really up to you. You've got quite a lot of time to iterate on your design. So once you come up with a rough design concept, there's plenty of opportunity to do some little tests within Fusion. The good thing about CAD modeling is that you can see how things fit together. So if you saw when I made the little error earlier where there was a gap, I was able to see that in Fusion in the CAD program. If I was to make that by hand, or I quickly sent this off, I might not know that that gap was there until I'd already made several of these, and there might be a significant amount of wastage because of that. But in Fusion, it's really quite easy to do an assembly, and then you can actually see and check that all the pieces are fitting together nicely before you send it off for production.